Hi everybody, here's your long-awaited video that was supposed to be done before Tuesday. Oh well. And then we're not going today, Thursday, because, well, it did say possible tornadoes, so that was a 5% reason, but we're really ahead of schedule. So what I'm going to do is give you this video and another one, and then you're going to have to download a little worksheet that I'm gonna, my last video, work through a couple of complicated examples with area, and then you're gonna take a quiz Tuesday, 7/4/14. So here we go. Area formulas. I gave you this printout on Friday. What? On Thursday last week? 2 weeks ago? What? Or no, Tuesday. Wow. Good start to the video. Before we had our Thursday off before Easter. Anyway, here's page 2. Okay, so what is area? Area, and you can read this. This is in your little printout, but real small and shrunken, is space inside of an object. So you could read all of this. It's two-dimensional, so flat piece of paper. What's the area of this rectangle? What's the area of this circle? And really the answer to that is how many blocks fit in there. Now, you probably can't see in the small printout, but you can see here, I hope, that how many blocks fit in this rectangle. And we'll go to the next page and discuss that or show what I wrote. If you count these blocks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21 little square blocks fit in this rectangle. That is why the area is said to be 21 units squared. So if it was like 3 inches and 7 inches, these blocks would be 1 inch by 1 inch. So when you say 21 inches squared, that means 21 1 by 1 squares fit in this object. That's why we label it 21 inches squared. I know this doesn't say inches, but I'm just saying why it's named that. Do squares fit in a circle very well? Well, no, they don't. So just kind of share out the formula. Area of a circle we're going to have to know is pi r squared. Well, area of a rectangle, not to skip over that, is length times width. That gets you the real easy, real fast, how many squares fit in a rectangle, which does fit nicely. But in a circle, it doesn't. So we're going to need this formula and have it memorized. Pi r squared, oh boy, that's not working very well. Pi r squared is the area of a circle. And you can count 1, 2, that the radius of this circle is 2 units. Or if I wanted to use inches again, just to hammer down a unit that you might be aware of. So pi 2 squared is 4 pi. Stop. This is the exact answer for the area. Exact means you leave pi alone as a symbol. All right, you don't touch the pi button. It's just like with radicals. The exact answer is the square root of 7, and that's it. As soon as you touch your calculator, square root of 7, and get the decimal, you have to round at some point. That makes it approximate. So when you type 4 times the pi button, pi is about 3.14, you get 12.5 blah, 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 blah. Well, you eventually round somewhere, so that makes that an approximate answer. So know the difference between exact and approximate. Very important. All right, now, what I did is, you as college students, this is, kind of, a little bit of high school geometry, so you should be more in tune with why formulas exist as opposed to like just flat out memorization. So the next thing, I kind of build on all of these formulas. That's great. That'll probably pop up 74 more times. That's going to be fun for everybody. Technology. All right, anyway, area of parallelograms. Here's a parallelogram. It's not quite a rectangle, all right, slanted, all right, but what we know is these two sides are parallel and these two sides are parallel. Hey, let's just do something. Let's cut off this rectangle, this triangle, right triangle, all right, so this part's right here, and then if the PowerPoint was active, technology, again, didn't let me do that, have the PowerPoint go, the show, but anyway, complaining. Cut, and then fly this triangle over to this side. All right. Once I do that, I now made this parallelogram a rectangle. So this is the height of this, well, rectangle, or the height of the parallelogram. And then actually this side right here ends up being this length as well, which is the base. Or this is the length and this is the width, or vice versa. So what we did was we found out, instead of length times width, because you don't really have that in the original picture, just change it to height times base. And therefore that is the area of a parallelogram. All right, so it's just a little play on area of a rectangle just by doing this little cut. So that should be very easy to figure out. So when I cut and put this over here, you could count the blocks and there'd be 18 of them fitting in there. All right, or 1, 2, 3, 4, 5, 6. 1, 2, 3. 3 times 6, 18. Let's move on. All right, area of a triangle. Hey, let's take this triangle just to speed this up, because this is just the, what do we know about this, or how do we derive this? Let's cut this triangle and make a copy of it, flip it upside down, and paste it on itself. Well, what's this a drawing of? Correct, that's a parallelogram. So what's a triangle? Half of a parallelogram, which I put right here for your convenience. All right? So if the area of a parallelogram is base times height, see how this is all building up? One thing builds on another. Area of a triangle is half that. So half base times height. So if I take this actual triangle and count 1, 2, 3, 4, and then count, yes, the height is the straight up down distance at any point you're looking at a triangle. In this case, if this is the base, this is the height. So 1, 2, 3, 4 as well for the height. So half 4 times 4 is the area. So that's how many blocks actually fit in this. So it doesn't look good. You can see these blocks are kind of cut off. But believe it or not, if you take these parts of blocks and put them together with the other parts, you're going to get 8 perfect blocks that fit in there. Real strange. Oh, for the love of dog. All right, area of a rhombus. Okay, I tried to do this, and actually if we had the PowerPoint active, you'd see this a lot better, but a rhombus is a parallelogram, so therefore the area could be base times height. So that's one possible area for rhombus. But what if you're given different stuff? What if you're given the diagonals? First of all, you know a rhombus, all the sides are equal. And then what you have to know about the diagonals is they bisect each other, but they're also perpendicular in here. So since they're perpendicular, you can treat one of the diagonals as actually the height, exactly, if anyone was guessing at home, the height of this triangle. And then this is the height of this bottom triangle. So we can count this diagonal, 1, is cutting the rhombus into 2 triangles. The second diagonal, each part of those diagonals represents the height of each of these 2 triangles. So a new formula you could use for rhombus is each triangle's area is half base times height from 2 slides ago. So what's the base of each triangle? Diagonal 1. What is the height of each triangle? Half of the second diagonal. See, I should have put a right angle in here. This is the heights. All right, so when I make a little substitution, B turns into D1, and then H turns into half D2. But how many of these triangles do I have? 2 of them. That's why I list this twice. All right, and then I do a little algebra. Half times half is a fourth. Yes, when you're teaching those little buggers fractions, you do 1 times 1, which is 1. 2 times 2 is 4. And then it's just D1, D2. Same thing with this. Then when you add fractions, oh, this is awesome. All right, 1/4 plus 1/4, you add the ones, that's 2. And then you carry the common denominator 4, 2/4. 2/4 is half. All right, so what do we do here? We derived a new formula. If the lengths of both diagonals are given, you don't have to do all of this. I did this for deriving purposes. All right? If you're given both diagonals, then this is another valid formula to find area of a rhombus. So you have two options. And again, when do I use which? It depends what's given. All right? If you're given this length and then a vertical like a vertical line, a line that represents the height of the rhombus and a base, then you want to use this. If you're given the length of both diagonals, then you're going to use this. All right, and that's what's going on here. All right, area of a kite. Holy crow, this looks all the same because it kind of is. What I did is I cheated a little bit. I should have made this more kite-ish looking, but what I did is I made this 2 marks, 2 marks, 1 mark, 1 mark, so I didn't make it a rhombus anymore. But what you need to know about the diagonals is one of the diagonals is bisected by the other diagonal, and they are perpendicular to each other. So the only difference with a kite compared to a rhombus is this length here is not the same as this length here, but I couldn't care less. We're going to call this the diagonal, the base of each of these two triangles, top and bottom. And then the diagonal that's bisected, since this is a right angle in this corner, that represents the height of each of those triangles. So what we've done is cut the kite into two. There's a little message again. Cut it into two triangles. I think that's what I was saying. I don't know. So many distractions. Anywho, blah, 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 blah. Same thing. Oh, and I lost that ability, so I'm going to pause the movie for a second. Oh, whatever. Okay, so anyway, same formula can be used for kite. All right, that can be used for rhombus because of the diagonals situation. Now, by the way, you can do the same thing with a square, because a square is a rhombus. Going back to this, so a square, we can use this formula, but you can't. And you wouldn't anyway, but you can't for a rectangle because the diagonals are not perpendicular to each other. So you got to be careful about that. All right? All right, let's go to the next slide.